And so we've reached the part of the course where we're looking at the intersection of two planes. And if you think about it, two planes are going to intersect in a line. So I've generated two planes here, and you can clearly see that they intersect in a line. Now there are a couple of special cases, but nonetheless this one intersects in a line. So the question is, how do we find out what the equation of that line is if we are given the two planar equations? And so to find the equation of a line, really what I want to do is I want to express x, y, and z in terms of a single parameter. And we've used different letters for the parameter, but let's say we're going to use the parameter t instead of s. Now, here are the equations of the plane that you see right here. And what I can do is I can try and eliminate some of these so that I can get things down to a single parameter. And fortunately, the way this is constructed, all I really have to do, I've got a positive y there and I've got a negative y there. I just have to add these two equations together and I can eliminate y. Now, if you remember doing elimination, you can eliminate any of these variables. This one's handy because I don't have to multiply one equation by a number to do elimination if I want to eliminate y. So I'm going to use that strategy because I don't like doing elimination with three variables. Okay, so there's my strategy. Let's eliminate y by adding the. So just looking at them, 2x minus x is x. Positive y minus y is nothing. 2z minus 4z is negative 2z. And so we're ready to go. Negative 4 plus 2 is negative 2. So there we go. We have eliminated y. And now we're down to just two variables. So we have x minus 2z equals negative 2. Okay, what I want is things in terms of a single parameter t. But really, z could be my parameter. I could choose a z value, and that would tell me my x value. So what I'm going to do is I'm going to say, oh yeah, let's let z equal t. Now, what that actually means is, so now I'm going to express x in terms of z, and then I'm going to substitute a t in for z. So now z is t, x becomes 2t minus 2. Simple enough. Now we just have to find out how to express y in terms of t. And of course I have two possibilities for relating those three variables together. The definition of plane 1 or the definition of plane 2. What I'm going to do is I'm going to substitute z is equal to t and x is equal to 2t minus 2 into the equation for plane 1. And so there we go. Instead of an x, I have a 2t minus 2 here. I'm leaving my y alone because I'm trying to get it expressed in terms of the parameter t. And where I see a z, I'm putting in a t, and that's all equal to negative 4. I'm just going to expand, and then I'm going to simplify, and I come up with an expression for y. So now if I do all the gathering up, basically what I see is, yes, I have x expressed in terms of the parameter t, I have y expressed in terms of the parameter t, and I have z, which of course I've just arbitrarily said, yeah, that's t. And so here I have it in parametric form, and GeoGebra has had the good sense to be able to generate the line itself just using what's known as the intersection command. And so there's the equation of the two planes there. And using the intersection command, basically I've wound up with this equation in vector form, negative 2, 0, 0, which matches up nicely with the parametric form, plus lambda times negative 2, 6, and negative 1. And so GeoGebra has basically given me the direction vector here, but the direction vector in the other direction. And if I want to just verify, I see that negative 2, 0, 0 is my position vector. I can actually turn that point on. There's point A over here in my plane, and I can see, yes, that point A lies on the line that is the intersection of those two planes.